Alrighty, now what we're going to do, everybody, is we are going to find the value of other trigonometric functions given a double angle's value. So we want to find all 6 trig functions of theta if we are given cosine of 2 theta. So what we're going to do is we want to relate cosine of 2 theta to another trig value with just theta. So we want to relate cosine of 2 theta to other trig values that just have theta. Now there's a couple of ways that this can happen. I'm going to do everything in both, since we're using our double angle identities, I'm going to go ahead and use mostly double angle identities so we can see how those work. But once you've gotten something, you can also remember already. So cosine is x over hypotenuse, or adjacent over hypotenuse, x over r, and so forth and so on. But I'm going to use double angle identities as long as we can. So we know that the cosine of 2 theta, because that's what they gave us. They gave us cosine of 2 theta right there. And if we want to find sine, I'm going to do 1 minus 2 sine squared of theta, because that is one of the values of cosine 2a. It's the last one on the left. It's the third one down. Well, we know what cosine of 2a is. We know the cosine of 2 theta is 4/5. It would help if I write what I say. We know cosine 2 theta is 4/5, and that's going to equal 1 minus 2 sine squared theta. Now what I want to try to do is solve this equation for sine of theta. So I'm going to subtract 1 from both sides, and I'm going to have to, when I subtract the 1, remember to get common denominators. So I'm going to do 4/5 minus 5/5. So that's going to give me negative 1/5 equals 1 minus 2 sine squared theta. All right, give myself some room. Oops, the 1 is gone. Goodness gracious. I subtracted 1 from both sides. There we go. So now I'm going to divide both sides by negative 2. Dividing by negative 2 is the same thing as multiplying by negative 1/2. So I'm going to get 1/10 equals sine squared theta. So to find out what sine theta is, I'm going to take the square root of both sides. And then I'm going to rationalize that denominator. I don't, because there's sine theta. Sine theta is plus or minus radical 1 over 10. But there's a square root on the bottom, because remember, this, we're really saying the square root of 1 over the square root of 10. So that's going to be 1 over the square root of 10. I don't like square roots on the bottom, so I'm going to move the square root to the top, keeping the bottom as a 10. And it's a plus or minus, but because if we look back, we know theta has to be between 90 and 180. This is quadrant 2. In quadrant 2, all students take calculus. Students S, sine and cosecant are positive, so the sine of theta is positive radical 10 over 10. So that's the sine of theta. I can do the same thing to find cosine of theta. So I'm going to take another double angle identity. The cosine of 2 theta equals 2 cosine squared theta minus 1. That's another double angle identity that relates cosine of 2 theta, which is what they gave me, to just cosine. So I'm going to do the same process. 4/5 equals 2 cosine squared theta minus 1. Let's add 5/5 to both sides. Multiply both sides by 1/2. So 9 over 10 equals cosine squared theta. Take the square root of both sides. So when I take the square root, I'm going to take the square root of 9 on top, and I'm going to take the square root of 10 on bottom, and that's going to be the cosine of theta. So when I break this down, I'm going to get plus or minus 3 radical 10 over 10. Because I don't like square roots on the bottom, I'm going to move it to the top. The square root of 9 is 3. And that's going to be the cosine of theta. Now when we go back to the top, we said we're in quadrant 2. All students, only sine and cosecant are positive in quadrant 2, so my answer has to be negative. Well, it said find all 6. I've got sine, I've got cosine. To find cosecant, we're going to take the sine and just flip it upside down. We hate square roots on the bottom, so this is going to become 10 radical 10 over 10. The 10s are going to cross out, leaving me radical 10. So the cosecant of theta is radical 10. We're going to do the same thing with cosine. You know, I'm going to back one step up before I rationalize the denominator. I'm going to go back to this guy. So the cosine of theta is radical 10 over radical 3. So that lets me know that the secant of theta is going to be radical 10 over radical 9. I'm using this one right here. And it's negative because we're in quadrant 2. So the secant of theta is radical 10 over 3, and that whole thing is negative. All right, there's 4 of them. Now we still need to find tangent and cotangent. Tangent of theta, remember, is going to be sine theta over cosine theta. So the tangent of theta is going to be sine theta, radical 10 over 10, times the reciprocal of cosine theta. So that's going to be 10 over 3 radical 10. So the radical 10 and the radical 10 are going to cancel out. The 10 and the 10 are going to cancel out. And we're going to find out that the tangent of theta is, let's see, those are all canceled out. So I am left with a negative 1 over 3. And then the cotangent of theta is the reciprocal of tangent, which would be negative 3. So those are all 6 of my sine, cosine, tangent, cotangent, cosecant, and secant functions. So that's example 2. I know it took up a lot of space, but then next example number 3 won't be so long, and we will see that in the next video.